Assalamu alaikum students, how are you? I hope you all are fine. As you all know that today is 16th of December 2022 and the day is Friday, and due to smog we are at home and this is your maths lesson. Yesterday we learned about unit number 2 and the name of unit is real and complex numbers. Real and complex numbers. Okay, let's recall our previous lesson. Yesterday we learnt about exponent, radicals, exponential to radical form and radical to exponential form. This is the sign of radical. Okay, this is the sign of radical. Not usually we say that this is the sign of square root, but this is not square root. This is a radical sign. This is radical sign, and the number inside this radical sign, for example 72, this is called radicand. This is called radicand. This is radical sign. And the number inside the radical sign is radicand, and sometimes we see numbers written in numbers written on the top of this peak, 3, 4, 5, 6, 7. This is base. This is base or index. This is index. Okay. So these are the parts of a radical form. Now we'll discuss how to convert this radical form into exponential form. What is meant by exponent? Exponent means power of a number, power of any number, variable, etc. So to convert this cube root of 72 into exponential form, we'll write round brackets. The number radicand, which is radicand, is always written inside this bracket, 72, and we write index in the form of exponent 1 over 3 always. 72 raised to power 1 by 3 is the exponential form of this radicand, this radical number. 72, cube root of 72, and in exponential form we write it as like this. And when we write in exponential form, now this is your base. This is your base having power 1 by 3. Is it clear? Let's see another example of how to convert exponential form into radical form. We also learned how to convert numbers into radical form. For example, we have 51 raised to power 1 by 4. This is the this number is written in exponential form. Yes. What is the base? Who will tell me what is the base of this number? 51. Great. This is your base. And what is the power? 1 by 4. Good. So to convert this exponential number into radical form, what will you do? This is the general form. What will be the radicand? The number inside the radical sign. The base number will always written as a radicand. So 51 will be our radicand. And what will be the index of this radical sign? Yes, the denominator of power is the index of our radical number. Okay, so this is the exponential form. This is the exponential form in which we write numbers having some powers. Exponential form. and this is radical form. This is radical form. So this is a quick recap of our previous lesson. Now today we will see some law. We will learn some laws of exponents. Exponent means power of a number. Good. Let me erase the board. Yes. Laws of exponent. Laws of exponent. These laws are very important. We'll use these laws to solve our questions further. We'll use in while solving our questions. So, watch the video carefully. First law is a raised to power m dot a raised to power n. This is base having some power n. Okay? Similarly, this is base having some power n. And this dot is not point or decimal point or anything else. This shows multiplication. This shows multiplication of two exponential numbers. This law says that if the bases are same but powers are different, and they are in the form of multiplication. If the bases are same and the powers are different and they are in the form of multiplication, then what will we do? We'll write base and the powers will add m plus n. A raised to power m multiplied by a raised to power n is equal to a raised to power m plus n. For example, if we have 2 raised to power 3 multiplied 2 raised to power 8, then this is equal to, bases are same, the 2 is base having power 3, here 2 is base having power 8, and the numbers are multiplying with each other. So what will we do? We'll write 2 base as a common and their powers will add 3 plus 8. What will be the answer? 2 raised to power 11. Is it clear, girls and boys? If bases are same and they are in the form of multiplication, but their powers are different, what will we do? We will simply add the powers. This is our first law. See another example. For example, if we work with variables like alphabets x, a, b, c, up to so on. For example, x square and y square. Can we apply this law to these x square and y square? No. Why? Because here base is x and here base is y. The bases are different. So, if I write x square and x raised to power 5. Now, can I apply this law now? Yes. This is the exponential number having base x and the power y and the power 2. This is exponential number having base x and power 5. These two numbers are multiplying with each other. This dot shows multiplication. Good. So we will simply write x and their powers will add 2 plus 5, which is equal to x raised to power 7. This is the first law of exponent. Is it clear? Okay. Now let's see second law. Second law is about division. If the bases are same, for example, x raised to power m over x raised to power n, but they are in division form. This fraction shows that they are dividing with each other. The bases are same. This is an exponential number having base x and power n. This is exponential number having base x and power n, and they are in division form. So what will we do? We'll write base as common x and m minus n. Their powers will subtract with each other, will subtract the powers. For example, if I have 3 raised to power 5 over 3 raised to power 2. Now there are two exponential numbers, 3 raised to power 5 and 3 raised to power 2. These bases are same but powers are different. So what should I do? I'll apply the second law of exponent, which says that we'll write the base as common and we will subtract the powers. 5 minus 2, which is equal to 3. 5 minus 2 is 3 raised to power 3. If the bases are different and they are in division form, we'll simply subtract the powers. Let's see. If I have x raised to power 4 over x raised to power 3, here bases are same but the powers are different. So I write x raised to power 4 minus 3, which is equal to x raised to power 1. This is the second law of exponent. Is that clear? Now, next law is, if I have a simple base, for example a, and two different powers m and n. There is one exponential number having two different exponents, having two different powers, a raised to power m and n. These are two powers. What will we do? Will we add a raised to power m plus n? No. Then, is there any other choice? Good. We will multiply the powers. A raised to power m multiply n. If the base is singles and there are two powers and they are multiplying with each other, so we will multiply a raised to power m brackets n. This shows that we will multiply these two powers m and n. For example, see this example, 3 raised to power 2 raised to power 5. Here we have a single exponential number. Base is 3 but we have two powers 2 and 5. So we'll write simple base 3 and the powers will multiply. 2 multiply 5, which is equal to 10. 3 raised to power 10 is our answer. Similarly, if we talk about the variables, like I have y raised to power 2 and, for example, minus 3. Will we subtract these two numbers, 2 and minus 3? No. This 2 and this number minus 3 both are multiplying with each other. For example, y raised to power 2 multiply minus 3. And what is 2 multiplied by minus 3? 2 multiplied 3 is 6. And we have plus minus minus. So y raised to power minus 6 is our answer. Okay? Next law is, if I have two bases with having a same power, common power, for example a b raised to power n, then what will we do? A and b, there are two bases and they are multiplying with each other. Their power is same, common, which is n. So now what will we do? The law of exponents says that the power will apply individually on each base. A raised to power n multiply b raised to power n. This power will apply individually on each base. For example, if I have number, for example I have number 3 multiplied by 5 and they is 2. So, according to this law of exponent, this power will apply on both bases. 3 raised to power 2 multiply 5 raised to power 2. If we talk about variables, for example, x and y raised to power 3. So this power will apply on both bases x and y. X raised to power 3 multiply y raised to power 3. This is our final answer. Is it clear? Similarly, if we have two bases and they are dividing each other, for example, let's see a over b with common base n. Same is the cases here. This power will apply individually on each base. A raised to power n over b raised to power n. For example, see in the case of number, we have 3 over 5 raised to power 2. So this is equal to, 3 and 5 are two bases, they are two different bases. Having common exponent, this exponent will apply on both bases individually, whether it is in the form of multiplication or in the form of division. 3 raised to power 2 over 5 raised to power 2. In case of variables, for example, x over y raised to power 5. So this number, this common power will apply on each base. X raised to power 5 over y raised to power 5. Is that clear? Okay. Next law of exponent is something having some number having negative exponent a raised to power minus n. ठीक है? Number having negative exponent. So what will we do? We will simply write in the form of reciprocal 1 over base with positive exponent. Now this number will, this exponent will become positive as we took reciprocal. For example, if I have y raised to power minus 6, then I can write it as 1 over y raised to power minus 6. Is it true? No. When we take reciprocal, the power will change its sign. This will become positive. 1 over y raised to power 6. Is it clear? And the last rule of exponent is, this is very interesting rule. Something raised to power 0 is equal to 1. Something raised to power 0, this is equal to 1. Anything, any number, any variable, everything number raised to power 0, this is always equal to 1. For example, if I say 10, this is a big number, and this raised to power 0, this is also equal to 1. 10 raised to power 10 multiply 10 raised to power 100. This is also, if we have power 0, this is also equal to 1. Now your assignment is to think how this is equal to 1. Anything raised to power 0 is equal to 1. How? Think about it. Think about it. How anything raised to power 0 is equal to 1? How? This is your assignment, okay? I'll collect your answers on Monday. Till then you can take help from Google, anything else, your textbook, any other resource, but you should have your answer. How something raised to power 0 is equal to 1, okay? same basis with different powers. What will we do? Very good. We will add the powers m plus n. Similarly, if we have same basis with different powers in denominator form, in fractional form, in division form, what will we do? This is equal to a raised to power m minus n. For example, these powers will subtract. We will subtract these powers. Third law is, if we have a base with two different exponents m and n, then this is equal to a raised to power and the powers will multiply m cross n. Fourth law is, if we have two different bases and their exponent is same, a b raised to power n, this is equal to a raised to power n and b raised to power n. This power will apply individually on each base. Same is the case for division. If we have a over b raised to power n, this is equal to a raised to power n over b raised to power n. Next law is, if we have a number having negative exponent, then what will we do? We will take reciprocal. We will take reciprocal and now exponent will change into positive. And the last law is, something raised to power 0 is equal to 1. Your assignment is to think about it, find out, and then I'll collect your answers on Monday in your maths lesson. Is it clear? Thank you, students. Allah Hafiz. Take care. Stay at your homes.